In this lesson, we're going to accomplish a few things. We're going to learn about resistors, which you see here. We're going to learn about breadboards. We're going to learn how to draw some simple circuit diagrams. Then we're going to light up an LED and think about Ohm's law. So to begin with, these are the things that you need. You need some resistors. So I have chosen 5 resistors. They just need to be a variety of different resistances. And then you need a couple of wires, and you need an LED. Any color, any size will work. And then you also need a 9-volt battery, and of course, your Arduino. So to begin with, what are resistors? So as you can see here, it's just a wire with some kind of blue thing. It could be blue, it could be brown, it could be black, but then there's a bunch of lines on here. So resistors do what they sound like they do. They resist the flow of current, all right? And so they prevent the current from flowing from one side of the metal to the other side of the metal. And so resistors, they come with these bands on them, so it's important to know how to read a resistor. So what that means is you look at the colors and then you pick out a chart, so like this one that came with my resistors, and use that to correlate a color to a resistance. So for instance, we'll start up here at the very beginning. So this resistor right here has a brown in the first ring, and then black, black as the second and third ring, and then black and brown for the last. So what that means is it's 1, 0, 0, 100. The multiplier is 1, so 100 times 1 gives me 100, and it is 100 ohms. And then the tolerance tells me how much that is plus or minus. And so for this one, it is 100 ohms plus or minus 1% tolerance. So that's kind of like the error whenever they manufacture these. What about this second one? This second one is red, red, black, black, red. Actually, I think that's brown. Sometimes it's a little hard to tell. So that means that this one is 220 ohms. So this next one is brown, black, black, brown, brown. So brown, 1, 0, 0 times 10. So 100 times 10 gives me 1,000 plus or minus 1%. So this is a 1,000 ohm resistor. What about this one? We have brown, black, black with red. So it's 100 times 100 or 10,000 ohm resistor. What about this one now? It is brown, black, black, yellow. So that's 100 times 10,000 or 1,000,000. So therefore it is a 1 mega ohm resistor. And so find a chart like this that you're able to read and make sure you understand how you can go from the resistor rings to the color, because I guarantee you, you're going to accidentally drop it, move it around. You're going to be like, which resistance is this? Well, you have to be able to figure it out based on the colors. Okay, so that's how you read a resistor. The next thing you need to know how to do is how to read a breadboard. By read a breadboard, I just mean how are things connected when you look at the wires. So everything that is in this column, so see how it's designated as a plus red? Everything is connected. So since the resistor is in this square and this resistor is in this square, they're all connected. So there is a metal wire that connects everything that is in this column. Same thing for this one next to it. This blue column here, everything that would be plugged into this blue column, even if it's not in the first 5, it's in the second 5, etc., everything's connected there. Same thing here. This column is connected within itself, and this column is connected with itself. None of those are connected to each other. So even though these two squares here look like they might be connected, they're not connected at all internally. So it's column and column. Whereas once you get into the middle now, it's based on rows. So A, B, C, D, E, that's 1, A, B, C, D, E. All 5 of those are connected internally to each other. So if you stick something into 1A, it's connected to something in 1E. Same thing here. Those 5 are connected together. Is 1E and 2E connected? Absolutely not. They are not connected internally. So columns are not connected, rows are connected. And the same thing for these 5. These 5 are all connected internally to each other. They are not connected internally to this one. So if you want to connect in a 1E to a 1F, you need to put something across the column in order to connect the two. So the way I have this set up right now is my positive is connected here with this wire, and then all of my resistors are in one of the positive slots. And then I have also selected them in their own cell. Why? Because I want to use this to choose which resistor I'm using. And so I can just move this cable so I can select a resistor. Then this one wire is in the same row here, this 5, I have it in 5H, and my LED is in 5J. Okay, and then my LED is jumping from my here into my negative here for blue, which is also connected to this black wire. Now typically I'll use like red for positive and black for ground or negative. So that's important to note here. How are things connected? Whenever students come to me and saying, it looks just like the schematic, I don't know what I did wrong, I guarantee you it's something in the breadboard. But then even within the breadboard, making sure your wires are not loose. Making sure your wires are not loose is important. Sometimes students have had really good luck with like taking needle nose pliers and kind of smushing, making sure it's good. You'll notice that's why mine are all jagged, is because like that one was loose. It was going to come out, and so now it's nice and secure. I should be able to pull and have it not come out. If I've done that, I'm good. So kind of make sure your resistors are all in there snug as a bug in a rug. Okay? Then the other thing you need to make sure is your LED. If you notice in your LED, you have one side that's longer than the other. The longer side is your positive. You can blow up a resistor one of two ways. If you send too much current through it, meaning you don't have enough resistors, you can blow it up that way, but then also if you connect it incorrectly. So if I were to connect it directly to a battery, or plug my negative terminal into my positive side and then my positive to my negative, something like that, you need to make sure you go positive. So I always go in my board, I go from my positive side, and I'm going to have current flow through a resistor, and then to my positive end of my LED to my negative side. So I run my board that way. Kind of have a good system. If you set up a good system and just kind of keep with it, it'll make it easier for you to troubleshoot and spot obvious errors in your breadboard. So positive to negative, which means if I were to plug in my battery down here, and you can see my positive end here and my negative end here, if I were to plug this in here, I can see if I'm going to light up my LED. But first off, I need to connect my current. So in this case, I'm going to go from my positive terminal of my battery to my positive up and down line by just simply connecting it here. Now, I could choose any resistor. Since this one is coming off of it, but there's nothing else connecting it, it's not in the loop, so its current's not going to pass through this one. If I stick this wire in here in the same row as this resistor here, now I have a loop. So see how it goes from here? It's going to go up and down this column, then it enters into this resistor, and then into this wire, back into the breadboard, up the positive terminal of my LED, through the LED into the negative, and then back through my negative wire down here. And so I have a loop. You always need to do that. Check and make sure you have a loop. If I thought these resistors were hooked up, I would be wrong. They're not hooked up to anything, so they are not part of the loop. Okay, so now we can plug this to my battery and see if we've got a light. Yay, check we do. Okay, and then I can move it and check and say, okay, well, how do my different resistors change my LED? Okay, so you saw how bright that was, and we can just keep going down. Notice I made my resistors so that my smallest resistor values are up high and my largest is down here at 1 mega. So keep watching, do this yourself, and see what you think. See how my light bulb is getting dimmer? And here you can't even see it really, it's so dim. That's a 1 mega ohm resistor. So I made this little schematic to help us kind of think through what's going on here. We have our symbol here, which is a battery or a DC power supply. So whenever it is connected to my battery, I've got the schematic. It goes, current flows from the positive to the negative. So it enters in through the squiggly line here you see. That's a resistor. And then it goes into my anode. My anode has this symbol here. And so notice the arrows are coming out of it. We will be doing a photoresistor soon, and the arrows will be going into it. It's just which direction is light coming in or coming out. So in this case, the anode is this terminal, the cathode is this side, and it's coming out. We always make sure that that's your positive. Your longer LED lead is your anode, your shorter is your cathode, and this is just a convention, okay? And then in my breadboard, I have in 9F, I have my 100 ohm, in 15F, I have my 220, and then my 1000, my 10,000, and my 1 mega ohm down here. And so you can see just by plugging it in, that we're getting a lot less brightness down here. And if I plug in my resistor here, it's going to be a lot brighter. Okay, so those are the main things here. So what happens as you increase your resistance? You should have realized that as I increased my resistance, my bulb became dimmer. What is that mathematical law that describes the relationship that we saw here between voltage, resistance, and current? Remember, that's Ohm's law, which is voltage equals current times resistance, meaning we're keeping our voltage consistent. My resistance is supplied here. Yes, there's a little bit of resistance inside the LED, but the main resistance is supplied by my resistor. And so the maximal current that is going to pass through my LED is going to be dependent on which resistor I choose and my voltage source. So as I increase my resistance, my current is going to go down because this is held constant. Okay, so increase your resistance. If you increase your resistance, your current is going to decrease, which is why we see it become dimmer. All right, so with this will help you. Just doing it with a battery, I think it's good to start here because this troubleshoots whether or not you have made errors in your breadboard and in your schematic. After you've troubleshooted and make sure you understood how a breadboard operates, how resistors function, and you've successfully lit up your LED, thus checking to make sure your LED bulb does in fact work, now we can switch over and try the same type of schematic, but now with our Arduino. Alrighty, I'm inserting my Arduino into my breadboard. I already have it plugged in, so that's why you can see it blinking. It remembered my code from the last lesson. But now, instead of hooking this up to a battery, I'm going to hook this up to my Arduino. But where, you may ask? Well, for my black wire, I have two options. You have a ground that's listed right here and another ground that's right here. The main thing you want to make sure is that you put that black pin in the exact same row that the ground is in. And so here I'll put my ground right here into that key here. Okay, now, which of these pins then is going to be positive? Well, you can either hook it to like 5 volts. That's one option, because 5 volts typically means power, but see, we don't get any lighting up. Okay, or what's neat is if we connect it to my D3 and see how it's lighting up even just touching it here. I'm going to light it up to my D13. The reason I did that is because D13 in most Arduinos is actually connected to your built-in light on your Arduino. And so your built-in LED, whenever it lights up, your LED is also going to blink. So that's pretty awesome. We can control it. But what if we want it to function separately from our built-in LED? And so we can do that. We can move this to a different one of these pins, and then we can program in our Arduino accordingly. So let's come over to the Arduino and to the sketch program, and let's pull up the same sketch that we had before. Now notice some things inside of this code. We were using the built-in LED, which is going to also be our digital 13. But we want to change that. It's important to be able to know how to control and change the pins as we're doing a code. So let's open up a new code, a new sketch. So this is one on Adafruit that I found, which is really lovely. It says, all right, we're going to define what LED is going to stand for. Meaning before, we were switching with the pin mode of the LED bolt-in. So we were saying, hey, do these things, change the output for the built-in LED. Now we're going to define it. Instead, we're going to change a LED, which we're going to call our pin, our LED pin, but we want that pin to be 13. And so in this case, that would be digital pin 13. But we can change this now from 13 to 7 to 6 to 5, whichever input we want to change it to. All right, so I have that code, and I've copied this code over, and I've called it blink red just because my LED is red. So I have this new code here. I'm going to move my pin back to 13. So notice this is the old code. I went ahead and ran it. This is the old code. I compiled and uploaded it just so you can see that, yes, it's still that same code that's running it. And when I've got it with my digital 13, my bulb is lighting up, and it's lighting up every second because we have 1,000 1,000th of a delay, which is 1 second. Okay, but now I'm going to switch over to this new code, which is the exact same thing, except for now we have LED. All right, so here you can see that when we uploaded it, it blinked, and then it's in digital pin 13. My digitals are typically outputs. My analogs are inputs. And so here you can see it's moving. Now what if I move it over here, maybe to D8? Now that we have changed it to pin D8 and it's not lighting up, let's see if we change the code and upload the sketch to D8. Now D8 should be in control of it blinking, and now you can see it is blinking. Let's change it to D7. Okay, notice it's not blinking. That's because it's looking for it in the digital output of 7. And I move it here. So if I push it and get it seated well, then it'll light up accordingly. And so there are lots of little places like that that the mistakes can happen. But now notice we can move my wires to different resistors, and it's going to change the brightness of my bulb. And so this is pretty quickly easy to see. The resistance will change your bulb brightness. Right now you can tell it's really dim, and if I move it to the last one of mega ohms, it all but goes out. And so using this Arduino, you can really able to see Ohm's law in action and control the blink rate. And this is just the first step in controlling extra things and little things that you're going to want to control when you make an instrument.